brain and then it's gone. Okay, so remember, we use implicit differentiation when we are trying to find the derivative of an equation that doesn't represent a function. So like power rule, product rule, quotient rule, all of that chain rule, we have previously been using to find the derivative for explicit functions like y equals to a rule that's in terms of a single variable, right? So we've been able to use those rules. So now it's when we have equations where you don't have the form y equals to some variable. Okay, that makes sense? And we looked at finding the derivative for x squared plus y squared equals to 1, so unit circle, right? And then we left off here. So we actually have multiple formulas here. Like if we wanted to find the derivative for a point that's on the top half of the circle, like the slope of the tangent line to a point that's on the top half of the circle, we technically could use this formula, or we could just plug in the x comma y into this single formula. Okay, and then you're not having to decide, well, is the point from the top half of the circle or the bottom half of the circle? Remember what we did? Like over here, we solved for y. So we had the two equations that make up the circle, and then we found dy over dx for each of those equations. Versus over here, using implicit differentiation, we found just the one formula that can find the slope of the tangent line for any point that lies on the circle, which feels a lot more efficient, right? So like if we want to know the slope of the graph at x equals to root 2 over 2, and the reason I chose to use unit circle here is we are so familiar with points on the unit circle, right guys? So familiar.
How is the question above different from the trigus?
I'll go over it at the end. I'll go over it. Slightly different. Similar, but slightly different. Now, remember, for x equals to root 2 over 2, aren't there 2 points on the circle, the unit circle, where x would be equal to root 2 over 2? Like this point? Yeah, so root 2 over 2, comma root 2 over 2. And then down here in Q4.
What are you doing? My applicants hasn't broken recently. Yes.
Okay.
Start your iPad.
So one option for finding the slope of the graph at x equals to root 2 over 2 would be like for plugging it in here and then also here, like thinking about the fact that, on the graph of x squared plus y squared equals to 1, there's 2 different points. So like you would end up needing to use both formulas, right? Like the top half of the circle formula for derivatives and the bottom half of the circle formula for derivatives. Or since we do know x comma y, for each of those points, we could think about plugging into our formula here. And I think somebody asked about this notation last week, but like if we're trying to find the slope of the tangent line at root 2 over 2 comma root 2 over 2, okay, we can think about evaluating dy over dx. And the way we show doing that is we write a vertical line, and then at the bottom of that vertical line, we write the point. And the reason I'm writing the whole point and not just x equals to root 2 over 2 is notice that in our formula for dy over dx, we have x and y.
I see.
Okay, so
How do you know that, like, how do you know to find it at root 2 over 2 comma root 2 over 2, not root 2 over 2 comma negative?
we're going to do both. Because the question says, what is the slope of the graph at x equals to root 2 over 2? So there's 2 answers to that question.
Oh, right, because it's not a function.
It's not a function.
Vertical line test. I know, but why are you drawing that line and then like the thing at the bottom?
That's the notation for showing what you're evaluating dy over dx at. So I'm evaluating dy over dx at root 2 over 2 comma root 2 over 2. So negative root 2 over 2 over root 2 over 2. I realize most of you could do this in your head, but we get negative 1. Now, if you wanted the equation, this isn't asked for, but if we wanted the equation of the tangent line,
Can you walk through the differentiating part one more time? How did you get?
We found it last time.
But isn't that for x? Isn't that for the equation x squared plus y squared equals 1?
Yeah, we're still on that one.
It's a
That's
circle.
finding the slope at x equals.
We're finding the slope of this tangent line right now. And then we're going to find the slope of this tangent line.
It's going to be negative 1 and 1.
No spoilers. Okay, so if we wanted to write the equation of the tangent line, we're like, whoa, we have a point and a slope. Y minus root 2 over 2 equals to negative 1 times x minus root 2 over 2.
Whoa.
Okay, and then the slope of the tangent line. My voice is almost back, you guys. Root 2 over 2, or maybe this is just it now. Root 2 over 2 comma negative root 2 over 2. Right? So plugging in for dy over dx, that point.
Is there a reason why after the line you write the root 2 over 2 comma negative root 2 over 2 so low?
It's just the notation.
When you're evaluating, it's a good question. When you're evaluating dy over dx or anything that's in this Leibniz notation, at a value, you're either doing like x equals to a, and it's used on the calculator too. Like I'll show you guys eventually on the calculator. And then it means that you're plugging a in for whatever the derivative is, or dy over dx, and then the like a comma b.
Huh. Okay.
So I can't put it in the middle.
It would be weird too.
Sad.
Okay, alright.
It would be weird too. I don't know. It's just, you'll see it in the textbook too. If you look through this section in the textbook. One second. Yeah.
I might be
Let's see.
making stuff up, but shouldn't it be?
Was that what you were going to say too, Drew?
Wait, why are you pausing?
Because it's supposed to be nice. I was just making sure you're paying attention. Right? So equation of the tangent line, not asked for, but why not?
So what would, because it's asking what the slope of the graph at x equal to root 2 over 2 would be, so would you say
1.
The slopes would be 1 and negative 1
there could be multiple slopes?
at each of those points. Yeah.
It's not a function, Drew.
Did you guys watch Schoolhouse Rock growing up
Yes.
too? Okay, we're not going down that road, but shh. Okay, so we found the slopes at each of those points to the graph of x squared plus y squared equals to 1. Okay, let's step it up a notch. Okay, let's do this one together just since we haven't differentiated yet today. So a little reminder. Remember, we are differentiating each side of the equation with respect to x. And when we do this, we're thinking chain rule, chain rule, chain rule. And I'll kind of go through and relate this to what I've asked you to do for homework, mainly like what you were asking about. So from here, this step indicates, hey, we're differentiating each side of the equation with respect to x. I'm okay if you guys leave off this step and go directly to saying, okay, d over dx of y cubed plus d, oh, yeah.
You can't just have the first step and then go.
You have to do at least one of the two.
One of the two.
One versus 2. Like you
Oh,
the first step, the second step?
Yeah.
You technically, you guys could pull out the 5 because of that constant multiple rule for derivatives.
Yep.
You technically could pull out the 5. It's your whatever your preference is.
So d over dx basically just means derivative.
It's just saying, hey, I'm going to find the derivative of whatever's in brackets here with respect to x.
So dy over dx is just
Derivative of y with respect to x, right? So our formula, that quantity represents how y is changing with respect to x.
So this is just how much change?
We haven't done anything yet. We're just saying, right now, we are communicating what we're about to do.
I see.
Because we are clear communicators, right?
Yep.
Yeah.
So in one of, you are writing down at least one of these two steps to communicate what's about to happen.
Wait,
We haven't done the calculus yet.
either one of those two is fine.
Either one is fine. Okay. Okay, so remember, we're thinking chain rule. So like I'm thinking of like the cubed as being the outside function, y as being the inside function. The square is the outside function, right? And then the y is the inside function. The 5y you can just think of like, you can pull out, it's maybe even easier if you think about pulling out the 5 here. But that's personal preference. It's not wrong to leave it in. So when we think about differentiating y cubed and we are thinking chain rule, we think derivative of the outside, leave the inside alone, and then times the derivative of the inside would be the derivative of y with respect to x, which means we end up multiplying by dy over dx. Good. Okay, and then we can move on to the y squared. So again, derivative of the outside, leave the inside alone, and then times the derivative of the inside is dy over dx. And then minus the 5's hanging out there, and then times the derivative of y with respect to x is just dy over dx. And here's where for some of you, you'll be like, hey, I'm differentiating with respect to x. I can just use power rule here. Or I think for some of you, when you're in the implicit differentiation mindset, I think it's helpful to just like stay in that mindset. Especially this will translate to whenever we're thinking about differentiating with respect to a variable that's not part of the equation, like t, which we'll be doing next class. So if I think about chain rule here, like you guys know the derivative of x squared is 2x. But if I think chain rule, and I go, okay, derivative of the outside, leave the inside alone, times the derivative of the inside is the derivative of x with respect to x. One way of writing that is dx over dx. For some of you, I think doing it this way will be helpful. You also know that that simplifies to be 1, right? Which is why the derivative is just the 2x. And then derivative of a constant is 0. Okay? We've done the calculus. Like that's all of the calculus in this problem. And then it turns into an algebra problem. You could go to an algebra 2 class. You could probably even go to an algebra 1 class and be like, hey, you gotta solve for dy over dx. Maybe not algebra 1. Algebra 2. Go to an algebra 2 class and say, hey, isolate dy over dx, and they could do the rest of this, like find dy over dx. Now it is just an algebra problem. So our next step is going to be to get all the terms that have dy over dx on one side of the equation and then the other terms on the other side. So we'll have 3y squared times dy over dx. And I realize some of you could do less algebra steps. Do what you're comfortable with. Plus 2y times dy over dx. Minus 5 times dy over dx. And then I can add 2x to each side. Remember, this is cancels. That's just 1. So I can add 2x to each side. And then from here, I go, hey, we have a common factor of dy over dx that we can factor out. And then to finish isolating dy over dx, we can divide on each side of the equation by the multiplication property of equality. Exactly. Exactly. We had calculus, literally, we were like, hey, we're going to use calculus right now. Then we're like, hey, now we're doing calculus, and now we're just algebra.
Well, just like a steep drop.
I just went for his water bottle.
Yours is over there.
I know. We need to move it or I'm going to accidentally drink out of
You
it.
should say on the recording whose water bottle it is.
Arjun!
Whoa,
Well, how did it wasn't here earlier. That's creepy.
His water bottle?
I swear it was not.
Arjun, stop leaving your water bottle in places.
He's probably in the closet.
What?
Yeah, let's do that.
What?
what happens if it's slow?
Arjun is ill, compared to the slope, and also somewhere sick.
Okay. Yeah, go ahead and find the slope at each of these points. So go ahead and plug in. So you're evaluating dy over dx, right, for 2, 0. And then evaluating dy over dx for 1, 1.
But you can't just say x is equal to 2, you have to go to the point.
You have to do the point because you have x's and y's in your derivative.
What? What's your...
Okay, dude.
Wait, if it's like something divided by 0 and then it's just.
What does that mean? What does that mean?
Vertical tangent line. I'm fine.
Vertical tangent line. I think vertical
It's
tangent
not.
is something else.
Four sides for each right now.
Like weird line bottoms.
Vertical.
Line bottom.
Oh, I need the lines.
Wait, what is this graph? I can't just write it like dy.
It's an interesting one. Let me see. Do I still have it in Desmos? I do.
What?
Check that out.
What is?
Oh my gosh.
What?
Isn't it interesting?
Yeah.
Wait, please show the camera.
Oh. It looks like.
What?
Can you show the camera again?
Oh,
It looks like
It's like a
nose.
so that ends up being the tangent line, the first one that you find at 2, 0.
Or the Colts.
Wait,
And then for the next one,
Plus 2, 5,
Oh, yeah.
6.
so for dy over dx at 1, 1, and what Art was mentioning.
Nose shows what?
wait, you only use this like line and then writing it on the bottom when you're doing derivatives of something that's not.
What? What?
No, I mean you could use it for any.
Like I can't just write dy over dx is equal to. Like if I wrote.
You should show what if you're evaluating dy over dx at an x value or at a point, you should show, like it's pretty much like a different version of function notation. Like it's just another notation of showing what you're evaluating at.
I can just write like m10 at 2, 0 and then equals whatever.
I wouldn't ever just write m tan. I would show evaluating f prime or dy over dx at like a specific value. So did you guys get 2 over 0?
Yeah.
We were like, what does that mean? It means undefined. The slope is undefined. And that means what type of tangent line occurs there? It's a vertical tangent line.
Isha, you look like.
Thank you, Alan, for representing it. Thank you, Alan. Oh, what's the other time you represented it? Like,
Yeah.
did you say parabola was like this? Like, what did you do?
This.
Yeah.
I don't even know.
And you guys, it's in the way that dy over dx is undefined that we know there's a vertical tangent line there. Like if it was 0 over 0 indeterminate form, we would be like,
This.
sharp corner. That would be like a sharp corner cusp. But because it's like think about it. Because it's a non-zero number over 0, that indicates a vertical tangent line, and that's because on the graph of the derivative, there would be a vertical asymptote at that x value.
That looks like a
Wait, why did you grab the does negative 4 if it comes x
It
does
does.
too?
It does. It's like a cartoon.
That was for 2, 0. So notice, you guys, notice the point 1, 1. Doesn't it look like there would be a vertical tangent line there? Like it looks like the slope is undefined at that point? Yeah.
Why do the derivatives of two sides of the equation equal each other? Just because this is how it is.
Well, if it didn't equal each other, then we could do it normally.
Yeah, because otherwise it'd be a function.
If it was y, yeah, if you have the rule as y equal, this is not a function, right? It doesn't pass the vertical line test.
Yeah, see.
But you could technically, even if you have a function, I showed you guys this the last time, even if you have a function, you can think about implicit differentiation.
Yeah.
Like that technically, that thought process technically applies, right? But this is dy over dx, and then this would be,
But it'd just be easier to explicitly differentiate with a function. Right?
yeah, exactly, it's more efficient.
Okay.
Although I do feel like every year I have a bunch of students that once they learn implicit differentiation, they kind of just start thinking implicit differentiation all the time.
Is that
It's
true?
okay, it's just not as efficient necessarily. Okay, let's continue. Everybody sees the vertical tangent line though at 1, 1, like why there's a vertical tangent line there? Okay, wonderful. Maybe I should reference, I don't want to forget to say something. All right, we're going to step it up a notch in difficulty.
Multiplication things then.
There's some multiplication and there's some products. Foot cramp.
Let's go.
Okay.
Product rule.
Shh. So we are going to differentiate this more complicated equation. I am going to take you through this one. We are going to get to one soon where I'm going to put you guys into groups. But not yet. Okay, so let's think about differentiating this equation. I'm just going to go directly to stating that I am differentiating each term with respect to x. Remember, I just need to do one of the two. I just need to make my statement that communicates that I'm going to differentiate with respect to x.
But the question's already asking you to do it, so would it be weird if it's not what you were doing?
Here's the thing. You're not always going to be told, hey, find dy over dx. Like next time you're going to be asked, find the rate of change of surface area with respect to time. And then, so like, let's get used to communicating what we're going to do. All right. Notice we have a product here. So our one calculus step in this problem, it was like our pre-calculus step, get it? And then our calculus step.
Because this is the step before the calculus.
I'm
I'm just crying inside. Anyways. All right. So we have a product, so let's do a little product rule. Thinking chain rule. So first factor times. To find the derivative of y squared with respect to x, we think chain rule, right? So derivative of the outside, leave the inside alone, times the derivative of the inside, okay, plus second factor times the derivative of the first, which is just the derivative of x with respect to x. If you want to write that as dx over dx, wonderful, great, do it. If you just want to write it as 1, great, wonderful, do it. Okay, and then plus, and I like to group, especially if I'm trying to retrace my steps, I like to group my product rule. So now I'm moving on, and guess what? I'm applying product rule again.
Yay!
Yeah! Okay. Not in this one. Well, if we had a quotient. All right, first factor times derivative of the second factor will be 5y to the fourth times dy over dx plus second factor times derivative of the first, which would be 2x times dx over dx. Or you guys know it's just 2x. Okay, almost there. Okay, end product rule. And then now you can either go, okay, I know I'm differentiating with respect to x. Derivative of x cubed is 3x squared. Or thinking chain rule, 3x squared times dx over dx. And then the derivative of a constant is 0. Okay, now we have just an algebra problem. So we can go ahead and solve for dy over dx. Right, so I want all my terms of dy over dx on one side. There are only 2 of them. Remember, multiplication is commutative. You can have, it doesn't matter the order your factors are in. I like to go in alphabetical order.
Oh, like x first and then
2xy times dy over dx. The other class was giving me a hard time this morning about like the fact that I'm like kind of particular on some stuff, but then there's other stuff like rationalizing the denominator. I was like, I don't care. Who cares about that? But then I'm like particular. I was like, you know what? If you teach this class one day, you have students simplify to what you want to simplify to. Oops.
yes.
I love algebra, I'm not gonna lie.
Okay, so then I'll have minus
Where did my minus?
y squared
What am I doing?
minus 2xy to the 5th plus 3x squared.
Where did the y squared?
It's like catchy.
Finishing the product.
Oh, wait, you're just.
Okay.
It might be helpful to go, that's just one, that's just one.
I need to take more stuff.
Or maybe take less steps. Okay, and then factoring dy over dx out. And then divide.
Oh, so y squared.
I'm going to put the 3x squared first because of alphabetical order, and I don't like having the minus first. And I'm allowed to do that because addition is commutative.
Because it's a free country.
Yes.
Wait, what if I? Do the club. Thank you. I live in one. America. I was thinking of a screeching sound if I could. But I can't. Let's work on that. Yeah. Let's think about that. That's what this does.
What?
You always say
Oh,
thinking
yeah.
about. You're always like, well, thinking about this, that.
Core memory.
Like
Do
when you're
I?
solving problems, you say a lot.
Oh, no.
From a this perspective.
I say that a lot. No, it's funny. Were any of you guys at graduation last year?
No.
Yes.
Megan kind of like
Oh, yeah.
said, like mentioned that in her, like she like made a statement about
Twin.
You.
using the word perspective.
Oh. Really, you always think, you're like, well, thinking about doing this, like that.
Gives me a new perspective of life.
I need to change up my vocabulary.
No, that's not my criticism, that's just
high
an
school perspective.
observation. And an observation, sorry.
A pre-lunch
Pre-lunch.
perspective and a post-lunch perspective.
Okay.
Just lunch. Pretty
We
much.
should do implicit integration.
Yeah, like before lunch and after
You need
lunch.
to get your
your
hunger pangs under
feelings are
control.
different.
Okay,
Doing
No. then you're kind of getting into like
Whoa, are we getting
multivariable
ahead of
calculus.
ourselves a little bit?
Whoa.
Whoa. She went ahead.
Okay,
Erasing all of it.
Here's the thing. Here's the thing. You have options. Some of you might prefer to leave the given equation. Do not.
What is this guy doing?
Like,
Yo, Alan, do not do that.
Please.
Alan, that was on the ground.
oh my god, that reminds me. I had a student years ago who he was like messing with his friends, and he had his eyelids flipped, and my back was still on, and I turned around, and I like lost my mind. Because that's something like when like kids would do that when we were younger, I would like I would have a physical reaction, like could not handle it.
out when stressed out?
Yeah.
Crashing out. Miss Dorset did not crash out.
I was like,
Can you say you
don't
crashed
do
out?
that.
Can you say you crashed out?
I guess so. I booted him out of class.
Literally crash out, bro.
Can you say I
Miss
crashed
Dorset
out?
crashed out.
Miss Dorset
Can you
crashed
say it,
out.
please?
Just crash out. Just crash out.
Okay,
Can
anyway.
you say it?
I don't know. You can leave this as this square root of x times y. You can also use like exponent properties and think of this as x to the 1/2, y to the 1/2, and just use product rule. I would like to leave as is, but if you feel strongly and want to do it differently,
you do you.
I feel really strong.
It's okay.
How do you
So I'm going to show that I'm communicating that I am differentiating with respect to x.
Okay, okay.
Well,
You know what? What's something I don't look like, Michael?
You can either pull this 2 out or leave it in.
Bagel.
Can we try the rest of it out?
no.
Yeah, please, yes, please.
Wait, what's dy over dx of x times y together?
Well, I would like to at least do the left-hand side with you guys. Now, derivative of 2x just ends up being, or x squared ends up being 2x, right? 2x. And if you wanted to put times dx over dx, that's great. And then this, remember, is the same thing as x times y to the 1/2 power, where we're going to want to think chain rule. Chain rule. Okay. So derivative of the outside. Derivative of the outside. Leave the inside alone. And then to find the derivative of the inside, we have to product rule. So first factor times derivative of the second factor plus the second factor times the derivative of the first. Okay. And then we'll have 4 on the other side of the equation. We'll have 4y times dy over dx plus 3.
Can you do the algebra part first?
You can think of that as dx over dx. Yeah, you can do the algebra. There's some negative exponents. Remember, no negative exponents allowed. And your final answer. So there are different ways you could go about this. I'm going to leave the screen on.
That was so unexpected.
What?
He said, oh, stinky. I don't know.
What?
That was so unexpected. Like imagine saying a derivative smells bad.
So many letters.
So many words.
Oh, shiver me.
Your name is so bad.
I see a lot of words.
Isn't it funny though? Because like this, literally, those first 2 lines are the only calculus, and now this is just all algebra.
That's kind of complicated.
How do I do that?
What's going
Is
on?
there
No need to
some
fear.
obvious?
Jay is here.
Solving really.
Yeah, I'll save the day, Michael. Don't worry.
Oh wait, no.
Oh no, no.
Yeah.
Yeah.
I wish it was that simple.
What? What did you say?
I
It's the
remember
pizza.
that.
Those were the days, bro. Those were the days.
Wait,
If you don't remember,
I don't know what's going on.
All I know is
How do you not remember it?
No, not the song. I don't know what's going on in my math.
Wait, you distribute the negative how?
Yes.
You can get rid of the negative sooner. It's what makes sense to you.
Is it
I
plus
think that
one?
makes sense.
Mr. Skibby.
Is it
Do not say skibbity boo bop, bro.
But then
You just said it.
side.
You just said it.
Okay, Lou.
You might say skibbity more than the freshman.
Me?
Yeah, you
Yes, Alan.
Just Dorsey says it wasn't the freshman, bro.
What? I heard Miss Dorset saying Scooby Doo Bob in a hot minute.
No, she said it.
I don't know what that.
Alright, when did she say it, Harry? Tell me.
Yesterday.
Bro.
Did she?
Bro.
Bro.
That's how we sound like.
It is.
Yeah, wait, I'm confused.
I thought it was Drew for
Wait,
bro.
I don't know distributing.
Yeah, it's such a carry one.
how did you do that?
Because you have to distribute to this sum before you can think about moving the terms from one side to the other.
So,
Wait,
okay,
how
so
do
you
you-
multiply.
So I distributed this product
Okay.
here and then here.
Okay, so then how does that equal what?
Hey, no,
Wait, what? 2x. Where's the 2x?
Oh, negative, okay. Negative, so,
Why
okay,
is it
what?
on that side?
I'm cooking up a storm.
Here's
here.
the-
Worry about me.
Alan, bro. What is
What do you
going
say,
on?
Alan?
Alan, what?
We missed our set. Confused.
Where did the
I
y go?
lost.
1 over.
I'm so lost in my mind.
Okay.
Carol, let's finish it, please.
Let's go.
Why?
We're not
Why?
cooking, we're
Oh my
cooking.
gosh, I'm cooking.
I'm cooking, bro.
Why
I
are you
swear I'm cooking, bro. I swear.
Why is he yelling?
Okay.
We're not, could you explain it for us?
Please, no, please
Yeah.
don't. Please just wait.
Before we can start applying properties of equality, like addition property of equality,
Okay, I think I got
we
it.
need to distribute this here and here so that we can get rid of this group.
Wait,
of
no, I'm
symbols.
totally almost done.
So distributing here, like this is just 2x,
The outer, like.
and then distributing this to the x dy over dx, that ends up being this.
That's
Here's my math.
Well, wait, I'm close.
Oh no,
X is
no.
multiplying it. 1/2 times x times xy to the negative 1/2 times dy over dx. I just rearranged the order.
Okay.
And then, since this is a minus, so minus
Oh.
1/2
That's
Y.
what
xy to the negative 1/2.
I feel like I'm
dx over dx is just 1.
The math is too complicated. Math is not math.
It's a
Dude,
call.
I'm literally guys, so then how do you get the, how do you solve for?
Right, because this
Wait, we have to simplify this, right?
Yo,
this was 1 and this was 1.
Divide by y times dy over dx.
You guys, it's getting too loud. So dy over dx, factoring this out, we're going to have complex fractions. You do need to get rid of the complex fractions because I said so.
Let's go.
Alan,
Why are you making it?
Alan, why are you this way?
Sorry.
Don't apologize.
You're not sorry. You're just sorry that you
You're right.
caught on.
This song.
Really?
Guys, this is a good math.
None of this makes any sense, there's so many numbers.
I want Jack.
There's more letters than numbers. Alan, did you get this?
It's turning into complete anarchy, is Jack.
How did you go?
No.
The first step on the screen and the second step on the
Wait,
screen.
how did you get?
Hold up.
How do you have 1 plus 8 in the bottom?
Did you move? Oh, you moved the 2x.
Let's see if I got it.
This.
It's this.
Try to get from what? Here to here?
No,
right?
No, it's first step to the
This
second
thing
step.
times this, it just turns into negative.
I
X.
just got all of the, I didn't really that dy over dx. I got all the dy over dx's
It's negative X.
Oh wait.
on one side and all the other terms on the other.
How did you just subtract?
Yeah.
Carrie and I are both done. Let's go.
So how did you?
You're so cool, aren't
How
you?
did the 2x minus half x times x over 5 become negative x over 2?
Exponent properties.
Yes?
But it's.
Move xy to the 1/2 to the denominator, which is the same as the square root of x times y.
It's a plus, not a
I'm
times.
literally
It's two
losing
terms.
all my
Two
brain
terms.
cells right
This
now.
is minus.
We can tell.
Yeah, this is minus, this is minus, this is plus. I think
What's
I
going
didn't
on?
do it.
You get-
I don't think I'll say you put-
Sure, but I rewrote it as a square
This is
root.
minus root.
Right? 1/2 power is the same as the square root.
But then you still have this, you have 2x minus.
I already subtracted the 2x.
Oh, you okay, let's try.
I did it all, I usually do it all at the same time. I moved all the dy from the x's and all the other terms.
That's such a quick-
Okay, shh. The final step here is to get rid of complex fractions. So we think, what version of 1 could we multiply by?
Always get rid of complex
Two
fractions.
XY. Oh.
Yeah, 2 root xy over 2 root xy because I don't like them.
You don't like.
And you have to be, you do need to be familiar with like getting,
Wait, can we have one more
Can we
minute?
just do,
Just like
can we
finish.
just do power?
yeah.
Can we just do power of 1/2 instead of root of this one?
Yeah, if you prefer, if you're more of an exponent kind of person than a radical kind of person, sure.
Not too radical, to be honest.
You're not too radical about radicals.
Wait,
It's a personality type.
Tubular.
That's totally tubular.
You're totally tubular.
I swear,
You're
that's
totally
like
not
tubular.
tubular.
Oh my god.
Carbon tube.
Can you scroll back?
After I finish this.
Radical, not so radical.
Shh, you guys, everyone is just making sounds right now. Can we just focus on what you're doing? Still just making sounds.
What am I saying? Something like
I keep cramping my foot.
Bigfoot? Oh, I didn't get it.
Did you say I have a big foot?
No, you're the one that said Bigfoot.
No, I did not. I said I have a cramp in my foot.
Oh, I thought you said Bigfoot. Okay.
Miss
Is
Leslie
this-
keeps talking about how she believes Bigfoot is real.
There was a teacher at my elementary school that like ended up leaving, and he like is a documentary maker, like he's been on the search for Bigfoot for like the last like probably, if he still does it, it's like the last like 3 years.
One of the-
What subject did he teach?
Eric Berkman.
Are you sure it's not with me?
Eric Berkman.
What subject did he teach us?
He was an elementary school teacher.
Wait, are you sure? Are you, wait, he might just be staging it for money.
No,
Wait,
he
it
did.
says Cliff Barrickman.
You look like Cliff Barrett.
No, I
No,
don't.
no.
This man's.
He's gonna be like, yo, we're on the hunt for Bigfoot. But in his mind, he knows there's no
Yeah, exactly.
Bigfoot, you know?
Cliff Barrett.
It's like the same thing with Dimsdale
Bigfoot.
in Scarlet Letter. Same thing as
Yeah,
Dimsdale in
just
Scarlet
Cliff
Letter.
Barrett.
He knows that him talking to his church people about his sins.
I'll
Like,
find it. Maybe
like,
his first
yo,
name was in Eric.
You don't have any sins, you're amazing. And then that backfires on him.
Wait, sins?
So he's talking about we're talking about the literary,
Al, what are you
adjacent,
Falling out
the literary adjacentness
That
of
helped
Dimsdale
related
and then
to
Scarlet
our
Letter
topic.
to just teach them his sources brought up.
Oh, just keep.
That's
And
right.
Scarlet Letter.
No,
We
big
didn't win a
advance.
fight.
That's just a heat.
Big advance in the same literary,
Yeah. I want to keep
he
bringing
knows drums.
There's only one
Big
man.
advance, it's the same,
The Scarlet Letter.
No, no,
I use the.
You know, JD Hicks was like,
Me, Pajarski.
he's like,
Maybe
And
this
you
is
don't
it.
What is up for you?
Anyways.
It is more
Ah. Anywho. What?
All right, go ahead and find the equation of the tangent line
when you
at 4, 1.
multiply by this to get rid of the complex fractions.
Oh, my thing is wrong. Let's just switch. She has the y with the y at the top up here and the x at the bottom.
What?
Doesn't make sense. Oh,
How do you do arithmetic again?
My x over time is here.
How do you do
My y is
arithmetic?
here.
Oh.
What's
You
one?
use your fingers. The numbers on your fingers.
I'm getting lost over
And
here.
then if you don't have enough fingers, you just add them. You take other people's fingers and you attach them to your
Rip
arm.
them.
Now you use the toes.
what are you talking about? I just heard that last part today.
Yeah, I don't remember.
It worried me a little bit. I'm gonna say.
So,
Equation, right?
that sounds like
16 times
Sounds
Sure,
like
we do
if you
that.
wanted to know the answer, you should have been
Why
listening
don't we just
all along.
not?
6
Okay.
times
This might be like, sorry.
Because this should be a y,
Which one should come?
right? Like this, you moved over.
But
So
the
this
y-
is what you moved over. No, your x was attached to a dy over dx. So you threw a dy over dx. You form on these.
I didn't calculate. I didn't calculate. I'm not doing this in my head.
4 minus
Oh, wait.
4 minus 4
That's
is
0.
I never said 4 minus
You
4.
said 4 minus 4.
I did not.
1 plus.
She said 4 minus 4. I
Yes,
said
she
4 minus
did.
4.
I did not.
It was clear.
Okay.
She's like,
There
she's
is no
like,
4 minus 4 in here.
it's like Trump saying he didn't say that. So like, he clearly did.
19.
Maybe he did, but you never know.
No, he
Guys,
didn't.
this is wrong.
What is like truth anymore?
I don't have trust.
What is wrong?
21.
Is this what you get?
Wait, hold on. 4 to the 1/2.
Wait.
What is 6 times 2,
Wait,
which is
did I hear
actually
my arithmetic wrong?
12
I think I got, I must have
plus
I don't see it.
5 to the 1/2.
Wait, here, you did your arithmetic wrong. It's 20.
Oh, it's 20.
Is it not to number 20? Oh, yeah.
Wow, you did your arithmetic right.
I did my arithmetic right. It didn't even
Why
have
did
to
it
do
take me
all my
so many
fingers seven
steps,
times.
though?
You gotta put what?
Wait, Harry, it's this, right? Wait, what? Where's the root 5? Where's the root 5 at? Where's the root 5?
I don't know. I don't see a root
Oh,
5.
it's 4 times 1.
You meant to
Oh,
roll
yeah.
out of it, please.
Not so
I
bad.
like to say.
No, think
Minus six.
Okay.
I need a second.
2
Oh, okay, no, I know.
incomplete pass. 4 down.
Like, let's not talk for a sec.
Yeah, that's some Zen.
Plenty of
Like,
That's some Zen, guys.
question?
Did you have a question?
So this is minus x minus b and y. Don't.
Okay. Well, then while you guys are finishing writing that, I'm gonna put you into groups.
Oh, sorry to go for my
How did you get that?
Oh, what?
confidence.
Is it not a negative number? It's slope?
It's negative over
I don't know why I got a negative number.
Because it's a negative, yeah, it's a negative
negative
over
over
negative.
negative r.
I got a
12
negative or a
minus 32 plus 1.
Negative.
And then-
Negative 4 minus 6.
Wait. So, well, my derivative was the opposite. I had the signs different on top and bottom, so it's still the same, but like, where did I go wrong? Where did I go wrong? This is like so exciting. But where's why is it 6? Yeah, I got 6 too.
Yeah.
Okay, so then this would be
Yes.
2, so that's 8 minus 1 is
What?
7.
I got you. I got you.
This is 8. Oh,
Yeah.
It's
very tiny.
What am I doing? 8 is 8.
Thank you. You're
So,
special.
yeah, it's still doesn't matter.
Negative 5.
What's going on there?
Gonna
File
Well,
them.
then-
Are those all the emails you have? Because I file them.
Still didn't work.
Isn't it beautiful?
Or maybe I 6,400.
Probably very low.
Between the start of this class period and the end.
6,000.
Okay, 1 year.
What's
So
the
is
A-Rock?
this
Wait, you can call it A-Rock. 'cause it's
minus-
C
I'm
subset
going with
K.
Dutch
So
Bros.
it's A-Rock, average rated class. Between the stars of class and class. What are your thoughts on that?
Let's look at the average change.
So that's going to be 8 minus 1 minus 12. So 7 minus.
Down facing for hours.
China.
Have
you seen the root?
How is it? How do you
Hold on.
react?
Oh, because you're missing.
It's a wholesome moment, but it's like.
This
I've literally seen that.
is
It's
4
Your best, the best one
x
is like just like
times
zero.
this
Very
is
low.
your
Zero.
x y.
Zero.
Yeah, to get prepared.
It was like,
Oh,
Shell, like,
yeah. 2x, right?
And then so
Oh,
times,
oh, wait.
yeah, so then it'll end up being 4x times the square root of x
Oh,
times
just like
y.
conversation, like general conversation stuff.
This.
That's
Wait,
super
how did I
I
get this?
usually just like send back for yes, respond.
So about to get
I
ready.
know, but then you're multiplying by 2 root x y
Oh, yeah,
over
I
2
was
root x y.
Okay,
You said, will the family?
let me put you into groups.
True.
1, 2, 3. What? What'd you do?
Nothing.
What'd you do? Show me your screen. No, turn it off. Okay.
What did you do?
1, 2, 3.
Two.
1, no. 1, 2, 3.
Boy.
I'm a.
1, 2, 3. 1, 2, 3. 1. Ones, twos, threes. Try the next problem.
No.
One.
Okay.
No negative exponents or
Michael
complex
is a
fractions.
Who's
This
a
is a
two?
one.
Yay.
Michael, do you know who that is?
No.
George Kittle?
Wait, Kyle, are you the one?
Do you know who that is?
No.
Wait, hold on, wait. Am I just a
What a disrespect. Will the family make me appear in the jamboree?
They are.
All
How
pro.
do you get the equation of this?
Okay, we got it, guys. Why is it so like
Sorry, I'm still using x minus 4.
We have to like.
Okay, got it.
Okay.
Okay. What's the answer? I got this.
We sledgehammer, right?
Me too.
Okay, we're done.
I would leave it as is. We don't.
Okay, you can just change that.
Yeah.
But first,
No, it should be a derivative. If a derivative of just dx over dx, it's basically.
Or actually, we can
Why are we just making sounds? You guys aren't even having a discussion. You're just making sounds. Oh, okay.
Yeah, because it's 1 times derivative of y over derivative, so dy over dx
chain
over
rule.
squared,
Times.
right?
Two
Plus 2y.
times 2, leave the inside the same. And then the derivative on the
2x
inside.
plus
What's the derivative?
Is it 2x?
y dx over dy.
Wait, you took the 100 out, right?
Yes.
It's 2x times.
Wait, is it?
Yes.
Wait, it's d over dx because you're taking the derivative is dx over dx. You got me? You got mine.
Wait, no, this whole
You got mine.
Wait, chain rule is times?
100.
Wait, is it
No,
It's times.
over dx of 100.
Well, everything-
Times the derivative of the inside, yeah.
Wait, if you have a constant on the outside, you also like.
You can pull it out or you can keep it in. It's up to you.
Okay.
yeah, so that's
Times
the
dx
derivative of x
over
squared plus the derivative of
Plus.
y.
Oh.
The addition.
What?
y
That's
dy
We have 2y times.
is equal to
You
100
move the 2, right?
Like,
So
derivative
that's
x, y,
the inside thing.
Yeah, so we can pull 100 out, right?
That's what I'm.
That's good.
Oh, that's what I'm saying.
Yes.
Yes.
Equals.
Yeah.
Equals.
times dy.
Wait, use part
So
of
100 times.
Is this right?
Oh, then you do.
Oh, shoot, F prime cheated.
So it's x,
Oh, no,
x
no.
times d
Oh, I did not
x
use
over
that.
dy, and then it's times x, or times.
Oh, wait.
Yes.
So we
X
get.
times dy over dx
Because,
Now
yeah,
plus
you
y
Plus
times d.
Wait, what's
X over
this?
Y.
Okay, that was part of it.
Yeah, right.
Yeah.
Oh, it's plus.
Times.
So 6x squared plus y squared
So we find the derivative of
Is this we got this side?
2 times x squared plus y squared.
Like,
100
equal
x
to
Times.
times, yes.
there we go.
Oh my lord, I'm not the Russian.
So we find, isolate the, thing.
Times the derivative.
Wait.
Okay.
Okay, isolate
God, God.
6 x squared plus y squared
Bartle? Alright, then.
But then we have to find
times
everything.
2y times dx.
We must be
dy.
doing something.
Then subtract 100 x times dx over dy times
We
y.
wouldn't factor it.
100 x y.
We didn't factor it, right?
Yeah, factor out the
You
dx
can't
over dy.
factor out the d.
Wait,
Wait, factor.
no, you have to, you have to multiply this by this and by that.
Oh, like
Distribute, that's what it is.
yeah, I'm just
Taking
taking
that
that, distributing one side to the left side of the equation, the other side to the right side of the equation.
So we're taking the derivative of all of this, and we're taking first the derivative. Oh, this is product rule, maybe.
6x squared
So, okay.
X,
times 2x, that's it, right? It's all the negative, so we can do that.
6, X.
The product, so first let's do x squared plus y squared times the derivative of this part, which would be this whole thing.
Wait, this is hard.
All over.
Where do I go from here?
X squared plus y squared
I
times
could,
x
this
minus
just feels like
xy.
Wait, where did I go from? Oh, wait. Factor of the dy dx plus
Yeah.
4y.
You can simplify it, we don't have to.
What I got sounds
Wait,
like,
did you just?
for sure our first step is
what I got sounds like what you guys said, is that
Very possibly, but then
I got,
very possible.
yeah, pretty much.
It's the opposite.
Wait, no.
I'm not simplifying this.
What'd you get? What'd
Wait,
you get?
this is near the bottom, so. What?
12? Wait, 12?
Why so long? What?
12y.
Okay, I don't know if this is right.
Because
The math
this
is not
not-
happening.
Because you distribute this.
Wait, no, wait.
How'd I get
Yeah,
12?
Oh, I see.
distribute
I don't know how I got.
X
Oh,
plus
6
Wait,
times
that's
2.
Plus.
sense.
Yep.
No, wait.
Look,
you can't distribute it, you can't distribute a d over dx, can you?
No, wait.
Where?
You can't because.
Oh, no.
You have to split it, product of this and this and this.
Yeah. I did this.
Oh.
Right here is.
Wait, did I get
This
this?
comes this.
I did not get
Wait,
this.
what is this?
Oh my
Yeah.
goodness.
So then
Oh,
it's
wait.
I didn't do
12y.
the 100.
12y.
Oh, wait, no, I did get this.
Yeah, I can do that.
I just didn't distribute.
Oh, okay, so I have this. I see. Wait, alright, I was trying to do it.
Wait, we can leave it in parentheses,
Where
right?
you guys even get it?
Be
Isn't it
Oh, sorry.
plus?
The derivative of x equals x times the
Oh, wait.
derivative of
Because
y.
the rule is.
yeah, so it's x times dy over dx plus.
But dx
Y.
over dy.
How would you have
x plus?
Yeah, I messed up on it. I didn't have some plus.
That's 100.
Wait, no, but this is for the y. So the
Yes.
multiply
So-
this to there.
100x.
Oh,
Is
No,
it
you
not?
need
Is
a
it
dx
not?
over
Is it not
dx.
like this?
Oh, I see, yeah, that's fine.
Okay.
It's not like that. Oh, sorry, no. It's not like
Okay, we got the right side.
Oh wait, you take out the 100.
Okay, you take out the 100. Then it's x times dx over dx plus y times dy over dx.
Yeah, so it's like this.
So you
Right.
multiply it out.
It's not this.
Remember, your algebra can be different than mine.
Yeah,
It doesn't need to be the exact same steps.
Here. dy.
I just didn't go correctly, so I imagine it has to be,
Yes,
I imagine it still has to be the correct algebra.
Wait, yeah, it's dy over dx.
Did you get the same derivative?
No,
Sure.
I just like
I
didn't
messed
factor
up.
this.
But,
I like did factor this little things, like I didn't put these brackets here because I thought it was.
You do that two steps. Wait, so you did derivative of the outside was like the only step here, and then times the derivative of the inside.
Okay.
Okay. This should be dy over
Let me redo this.
2x.
I can't
Maybe
tell
we
if
do
that's
that.
the same thing.
Wait.
I don't know.
2x.
100.
Shouldn't that be
Y.
then times y
Why would we do
squared?
100 y.
Whoa. Oh wait, no. Sorry, never mind. Just kidding.
Oh,
Just
my
being
gosh.
close.
Yeah.
Okay.
And
Plus
then
2y dy over dx. Okay.
x
Uh huh.
plus 100x.
Okay.
I mean, this
I
is
got
where,
it.
this is where it went wrong.
I didn't write the same one as
You
Okay,
distributed.
100y minus 6.
Sure.
Yes,
Here's what
distributed.
And then here.
Okay, plus this there.
Yeah.
That's basically that.
Oh, isn't it?
Yes,
Well,
12y
The bottom
and
was
then times
You have the same
x
thing.
squared plus
Yeah.
y squared times dy over dx.
Yeah, it
Right
is.
here.
Yeah, it's the same. Wait, no, it's not. Yeah, it is.
that would be,
Wait, is it?
Let's hope.
Why'd you do such a space?
because I found it wrong and I saw, I looked up there and saw
Oh,
that was
because
step,
you
but like
wait
for
for
every
3
step,
and then you
so I
bring
pulled
out
this
the
down so I could try that.
It helps me, even in my own work, I always write the,
Bro, I remember seeing like.
next day,
Very
or
true.
like, hear about this,
I started looking when I was like a baby.
and here,
Lucas Woslak?
just to visualize.
Lucas
that.
Woslak?
Yeah.
Ari.
That's my
Billy.
Crazy.
I love those.
It's like an old, that was an old.
I'm confused how from like
Eve, we're an Eve, bro.
Shouldn't this value be x?
Don't need.
Cause
Nice. And Kale is my best friend.
That is an X.
Oh, and
wait,
this
is this an x?
Yeah.
What's his name? Thomas?
Are you sure?
Spoil it. Last name. I knew his last name.
Compare it to my Y. Do those look the same?
Oh, come on. That looks like a y.
It's an X.
Alright, now we're saying
Gonna do, like,
Jeez Louise, man.
That guy.
Wait, I think we can do that.
It's a lot of
Harry's
time.
knitted behind Sophia.
He just kind of like disappeared off the face of the earth.
I think you might have got.
Okay, one more minute and then we are going to try the next.
I don't remember.
Wait,
It could have been like. I don't remember. That's pretty soon. Okay.
We're going
We don't need to simplify, right?
We don't even have the power.
we get
Tricky.
way tricky with it.
Which is actually way easier than what we just did.
Oh, no. That's it different.
I don't believe you this.
If you're done and you want to peek at the next one, you can try it.
oh,
How much time will it cost? 6 minutes.
Peek at the sun.
Will you post these notes?
Just
Peek at the sun.
Wait, what?
Sure.
What was the
I'm a
difference?
big fan of peeking
Oh
at.
wait, this is.
yeah, I like looking at the sun directly.
I don't know.
The more direct, the better.
That's what I'm.
Flu shot.
Okay, we got it.
Huh?
I'm getting a flu shot right now.
Are you afraid of needles or something?
I need to do that. It's just the feeling crappy afterwards.
Oh,
Sucks.
I'm also afraid of needles. Sorry.
And then equals.
Wait, but I don't know if that's how it works.
Well, you don't need equals.
Okay.
So equals 1.
Cosine?
I could not tell you.
Cosine?
Yeah, cosine
Y.
times
Whoa.
y over dx.
Okay, one more minute and then I want
We're
to
getting somewhere. We're getting somewhere.
switch to the last one.
N minus 1.
It's like the
The outside be inside. No, it's not power. It's
Is
not
this
powerful.
outside?
It's not powerful. You just find the
Oh
outside.
yeah. Oh yeah.
Cosine y and the inside is the derivative
dy
of y.
over dx
Yeah, so dy
equals
over dx equals 1 over
cosine y.
Yes, sir.
Wow, that's so much better.
Oh yeah.
And then dy over dx
I think dy over dx equal to
equals to
4.
secant.
secant 1.
Oh yeah.
The answer to the trigonometric one is secant 1.
It's one way to write it.
Let's go.
Okay,
Sine y equals
just to make, and like Drew just requested, I can post these notes. This last one. So secant of y, or sorry, no, sine of y equals to x. So not even thinking about like what this represents necessarily. If we're just thinking about differentiating with respect to x. Okay, we think, okay, chain rule. So sine is the outside, and then y is the inside. Derivative of the outside function would be cosine. We leave the inside alone, and then times the derivative of the inside would be dy over dx. And then the right-hand side would be derivative of x with respect to x, so dx over dx, or 1. So then to isolate dy over dx, you're like, oh, whoa. There's only one step.
This is so loose.
Now here's the thing.
Never mind.
Oh.
We're actually not quite at this point yet, but does anyone recognize what this equation is? Arcsine, another way to write this.
I was thinking of arctan and arcsine at the same time.
Is arcsine, very good, Michael.
How did bro know?
Is arcsine, do you guys remember the domain and the range of arcsine, inverse sine?
Oh.
What's the domain of inverse sine?
Is it?
-1 to 1.
Good.
I don't like domain.
And then the range is
Negative
Then they need a positive.
Remember, it's the inverse.
All real numbers?
No, remember how we had to
Negative
risk
-1 and 1 to
It's
Pi over 2.
is involved.
It's like negative pi over 2 to pi over 2.
No, what is arc sine?
Inverse sine.
The
The
sine
inverse
to the power
sine
of
function.
I think I didn't do very good.
I think it's the reason I got.
Right? This is the same thing as this.
Junior.
Anyways, we're gonna pick back. I'm bringing this up for good reason, but we'll pick back up here at the beginning of next class. This is one of the representations of the derivative of inverse sine, but this is not typically how we represent the derivative of inverse sine. Dun-dun-dun. Okay, so that's actually not even this chapter. That's a different chapter.
Are we cooked?
Down the line.
Down.
What is that? I don't remember.
Wait, your
Exactly.
boss chief killed?
Dude, looks like a.
Dude,
Is that the body count?
And then you guys, the next class we will do, we will use finding the second derivative in implicit differentiation. You guys, you have homework on implicit differentiation. Mainly to go back to your question from the beginning.
Yeah, how's that?
I'm gonna crash out for 5 minutes.
Notice it's solve for, it's differentiate with respect to t instead of x.
D over dt.
Oh, wait, no, that was a rough end.
So you're finding dy over dt.
Well,
No, wait, really.
Think about it.
It's like,
no.
it's the d over d of t on this side and the d over d
Go Bob
of this
again.
side. So finding d over
Oh my.
d of x over there. D over d of t over
What is
Haley with like d x over dt and like dy over dt and you end up isolating dy over dt.
Let's see, is Ari in here? Or Archie?
He's homesick.
I kind of get it.
Okay.
Wait, I'll figure it. That helped though. I like
The usual suspects.
Hey, remember when what was called Arjun and Artie? I called them Artie.
Thank you, Miss Sosa. Good lessons.
It's really hard to take me seriously.
With your face painted like
That's
that.
so mean.
With having your little
It's literally Kojo every time she comes in like a Pink Panther onesie and starts talking about the